Let's look at calculations involving the transformer. Now, let me just draw a general symbol for the transformer. Alright. So here, what we have is the symbol that is usually used to represent a transformer, an iron core transformer. You probably would be familiar with that. So over here, that's connected to the source of power. For example, a generator, and of course it has to be AC. Transformer doesn't work with DC. And then over here you have the load. Alright. So you have the primary side, sometimes referred to as side 1, and you have the secondary side of a transformer, sometimes referred to as side 2. Now, you have the magnetic flux around, or well, you have a magnetic flux around a conductor anytime you have current flow through the conductor. Alright? Now, when you wrap the conductor in the form of a solenoid or a coil, you have a concentration of those magnetic flux here on the primary side. You wrap a certain number of turns on the coil. And by the way, let me just do this. Generally, you would know already. Sometimes you have this symbol for a transformer as well, where you have two legs of the transformer iron core. Alright? And the core itself would concentrate the magnetic flux. Although in reality though, it's much more efficient to have an arrangement like this, where you have the primary coil wrapped around the middle core. The secondary coil is wrapped around the middle core as well. Alright? Both of them wrapped around the same leg of the iron core, or I should say middle core, the middle leg. You have much more efficiency in this case. Alright? But in any case, every time you wrap you make one turn of wire around the leg, you have one turn. When the time you make a complete wrap. So this now, when you wrap the primary coil that's connected to the source, you say the number of turns in the primary coil, that's N1. When you wrap the coil that's connected to the load, you say N2, the number of turns on the secondary side. Sometimes NP and NS are used. I'm going to use N1 and N2. Alright? The voltage that you apply to it is V1, and the voltage that you get out to the load is V2. Now, here, N1, right, divided by N2 is equal to V1 divided by V2. Because what happened now, as an example, you have N1 being 1000 turns for argument's sake, and N2 being, let's say, 500 turns. You apply V1, you apply, let's say, you apply how many voltage? 600 volts to the primary side. So here you have the primary connected to the generator. You have the secondary connected to the load, whatever the load is. You have 600 volts applied. You know that N1 is 1000, N2 is equal to 500. What is the voltage applied to the load at N2? I mean at V2, the secondary voltage. You're going to have N1 is 1000 turns divided by N2, which is 500 turns, is equal to V1, 600 volts divided by V2, whatever it is. Because remember, V2 you don't know. Put a question sign there, you don't know. Now when you transpose this equation, you could multiply both sides by V2 and multiply both sides by 500. In other words, cross multiply. You have 1000 V2 is equal to 600 times 500. Then you divide by 1000, so V2 is equal to 600 times 500 divided by 1000. Right? If you divide, we're going into the mathematics now. Let's say the 600 is 6 times 100 times 500 divided by, and 500 is the same thing as 50 times 10, right? Divided by 1000 is 100 times 10, right? So this 100 over 100 is 1, so that's gone. 10 over 10 is 1, that's gone. So it's 60 by, it's 6 by 50. So it's going to be 300 volts. Alright. So now you see it is 300 volts. Let's put it here. We have 300 volts. Alright. So N1 divided by N2 is the turns ratio. V1 divided by V2 is the voltage ratio. So here, if what you have to the load on the secondary side is half of what you have on the primary side in terms of the number of turns, then the voltage will also be half. Now you put in a higher voltage and get out a lower voltage. Since the voltage is reduced, right, then you're going down from 600 to 300 volts. So this is a step down transformer. You're stepping it down. You're stepping the voltage down. So you see that? Alright, we'll soon do another, we're going to do another example in another video.